Guys, welcome.
Hi.
Hey guys, I think that's everyone, but let's wait one more minute just in case, and then we'll start class, okay? Okay, let's go ahead and start class. So I'm Anna, I'm gonna be your teacher for this semester. Do you guys wanna start by introducing yourself? Just say like your name and then your age. Let's see. Does anyone wanna start? You just unmute and talk out loud.
Can you say hi?
Hi,
Hi, what's your name?
Jaden,
And how old are you?
7.
Nice. Okay, let's see. Alan, you wanna go next?
I'm Ellen and my age is 8.
Oh, you're 8? Nice. Amy, you wanna go?
My name is Amy, and I am 8.5 years old.
Oh, very nice. Hannah?
My name is Hannah and I'm 8.5 years old too.
Oh, nice. You guys are both 8.5. And then I think the last one is Luca.
Luca.
My name is Luca, and I'm 7, and I like to play video games.
Oh, very nice. Yeah, video games are fun. Oh, Scarlett, welcome in. We're just introducing ourselves right now. Do you just wanna say your name and age?
It's waiting. Then enter again. Enter again. Please.
Scarlett, did you want to introduce yourself?
Okay.
How old are you?
What?
How old are you, Scarlett?
I'm 9 years old.
Oh, very nice. Okay, let's see. I think we just had some other new people join in. Forgot who we got to. If you haven't introduced yourself, then you can just unmute and then say your name and then your age. Let's see. Alan, did you want to introduce yourself?
Yeah.
Okay, I think that's everyone then. So let's go ahead and start. Let me share my screen. Let me know if you can see everything, okay? So we are going to, can you guys see?
Yeah, we can.
哦，对，有男生有女。
Nice. So today we're going to be starting
It's waiting.
shapes. So first we have these monster friends that are going to be introducing us to this lesson. So everyone gets toothpicks, right? So what letters can we create with just using 2 toothpicks? So we can make an L, a T, a V, and someone broke their toothpick out to make a G. So this blue monster says, my T and Lizzie's L each have 1 vertical toothpick and 1 horizontal toothpick. So what do vertical and horizontal mean? So a vertical line is a line that goes straight up and down, and a horizontal line goes straight across, like the horizon, right? It just goes straight across the surface. For the L and V, the toothpicks touch at the ends. They both make angles. So what's an angle? So when two toothpicks meet at the ends, the shape they make is called an angle.
You understand that?
So what's the difference between this angle made by the V and this angle made by the L? So we can see that this angle is larger, right? The distance between the two toothpicks is larger, right? And so we're saying, what do they mean by larger? So the sides are the same length, but the L is more open, right? If we put the V on its side, we can open it more to make an L. The angle that the L makes is called a right angle. Where can we find right angles? So the corners of things, right? The corner of your computer screen is probably an L, or like the edge of a paper is also an L. Those are all right angles. So does anyone know what we call an angle that is smaller than a right angle? Does anyone know? Lydia, do you know what an angle that's smaller than a right angle is called?
It's called a acute angle.
Yeah, right? So an acute angle is anything smaller than a right angle. And then does anyone know what an angle larger than a right angle is? It's an obtuse angle, right? So here we can find some obtuse angles, right? So there's one here, right here on the top of the roof. And here on this roof too. All of the angles inside the stop sign are obtuse, right here, right? All of these angles are obtuse because, let me choose a better pen color. All these angles are obtuse because they're bigger than 90 degrees, or a right angle, they're bigger than a right angle, right? So this is an obtuse angle. And so now let's do some practice problems. So if you want, you guys can use the raise your hand function or turn on your videos and raise your hands too, okay?
I can't do the raise your hand function.
Oh, you can? Okay, well, you can always just raise your hand in your video, or you can just unmute and talk or send a message in the chat, okay? So when two lines meet, they make an angle, right? If we connect these dots, then we make an angle here, right? This corner. If the lines meet at a perfect L, the angle is a right angle. Any angle that's smaller than that right angle, right? So here, if we have a right angle, anything smaller than that is an acute angle, and anything larger than that, like this angle, is an obtuse angle. So let's see if we can use this diagram to answer some questions. So what type of angle is formed by connecting A to B to C? So first, let's find our point. So we have A here. Let's connect that to B. And then let's connect to B. So my line isn't super straight, but let's connect B to C. So what kind of angle does this look like? Does anyone know?
We really can't see
Oh, you can't.
you working it out because we don't see your mouse.
Oh, you don't see my mouse? Okay. Here, let's see. Can you see what I've drawn on the screen?
No, we just saw.
No.
We just see this.
No, we just see the worksheet.
Yeah.
Oh, you just see the worksheet? Okay,
Yeah.
okay, give me
Your
one.
mouse is invisible. Same as the drawing, it's invisible.
Yes.
Okay, let me see. If I can put this one on then.
I still don't see the homework.
什么？这是 accurate，这个叫什么？这是这个是 right angle acute to side angle。记住没有
Okay, can you see what I just drew on the screen or no?
？Can you see？
No? Oh,
No, still no. We still can't see it.
I've got a Beast Academy book.
Still no. Okay, give me one moment then.
Len, you were in yesterday's class with me in math class, right?
数学
Because if you weren't, then why do you have the Beast Academy thing?
Okay, let me try again. Let's see.
Better work this time.
Yeah, I hope it works. Okay, so if I draw or highlight, can you guys see now?
Yes.
Okay, so you guys can see this? Okay. There we go. I don't know why it wasn't working earlier. Okay, so let's see. So now let's do question 1. What angle is formed by connecting A to B to C? Right, so if we draw an angle like this, from a line from A to B, and then a line from B to C, you guys can see this, right?
Yes.
Okay, so what kind of
It is
angle?
visible now.
Yay, that's good. So what kind of
This is
angle?
the right angle, so.
Yeah, right. It looks like a right angle. It looks like the corner of a piece of paper or the corner of our screen, right? So this is,
a rectangle.
yeah, the corner of a rectangle. Gia, did you raise your hand? Did you want to answer the next question for us?
Yeah.
Okay, so let's see. Let's look at the next question then. So it says, what kind of angle is formed by connecting D to E to B? So we have D and E, and then B.
D to E. That's acute.
So let's see. Does it look bigger or smaller than a right angle?
Well, it's B to E to D.
Oh,
It's
sorry,
not what.
B to D.
Yeah.
Right, so we have B to E to D. So right, does this look smaller or bigger than? a
No,
right?
it's D to E to B.
Yeah, D to E to B.
But somebody said B to E to D.
你说答案吧。
All right, so let's look. So if we do
Cute.
D to E to B or B to E to D, it's the same. It doesn't matter which direction we go. We can start from either end.
你说想
Acute.
Yeah, right. It's acute. It's smaller than a right angle, right? The right angle we just looked at, it's smaller than that one. So it's an acute angle. Okay, and then what about question 3? What kind of angle is formed by connecting A to E to C? So we have A to E, and then E to C. Alan, you want to answer this one? Alan, did you want to answer this question?
Looks like a shape of a stop sign.
Abuse.
Yeah, obtuse. It does look like the edge of a stop sign, right? If we did more of these, it would probably look like a big hexagon.
Yeah.
So this one's obtuse, right? It has a bigger angle than our right angle from earlier. Okay, so let's do a couple more. So what kind of angle is formed by connecting C to F? So C to F, and then F to E.
Oh, it's almost a triangle.
Yeah, let's see. Luca, you want to answer this question?
It's an acute angle.
Yeah, acute. Great job, right? Because it's smaller than a right angle. Okay, so great job. So here, we're going to do some mazes. For the following mazes, trace a path from start to finish that has only acute angles, right? So we're going to be trying to get to the finish line using only angles that are smaller than a right angle. So in the solution below, all of the
Wait,
angles,
how long is a right angle again?
a right angle is 90 degrees. So right, looks like a corner. This corner is 90 degrees, but we don't have to worry about that right now. All we have to know is a right angle, whatever is bigger than a right angle, which is obtuse, and whatever is smaller than a right angle, which is acute. So right, all of these angles are acute, right? Whenever we turn, we're making an acute angle. In these paths, we can see that it's not correct because these angles are bigger than bigger than a right angle, right? So these are all obtuse angles, right? This is an obtuse angle, this is an obtuse angle. So that's why we can only have this solution. So let's see. So let's practice with question 7. Let's see if we can get from the start to the finish using only acute. So we go right first, and then I can't go down, right? Because it's an obtuse angle. So we're gonna go up and just keep following the path. And then we could go up here, right? Or no, we can't go up, right? Because this is bigger than a right angle. So we're gonna go down. Just keep following the path. And we can go up here, but we can't go to this right branch because that would be an obtuse angle. So we just keep going up. And now we can go right. This is an acute angle. And just follow it to the finish. Okay. Let's see. I'll turn on annotate, and then let's see if we can, does anyone want to help see if they can solve number 8 by getting to the finish with only acute? Okay.
I still don't understand what these two words mean, so I don't really think I can do it.
Oh, you don't know what acute and obtuse mean?
Yeah, when you explained it, I just didn't understand.
Okay, let's go over it again then. So let's go over the first one. Let's go over the easiest one. So if we just have a right angle, right? This is a right angle. It'll be like the corner of a paper or the edge of your screen. It'll be 2 lines, one that is completely horizontal and one that's vertical, right? They meet to make this corner that looks like the edge of a rectangle or edge of a square. Does that one make sense?
Oh.
Okay, so that's a right angle. And then an acute angle is anything that has an angle that's smaller than this right angle, right? So our angle is this gap right here. And so anything that's smaller than that is an acute angle, right? If we have the same vertical line, if we cut that in half, this angle is smaller than this angle, right? We could fit this pie piece into this corner, right? These 2 sticks are closer together than these, right? So an acute angle, this is an acute angle, is anything that is smaller than a right angle. And then an obtuse angle is anything that's bigger than a right angle, right? So if we have this line, and we draw another line, this gap is bigger than the right angle, right? These 2 sticks are further apart.
Oh, I get it.
Yeah, so this is going to be an obtuse angle. So we just have 3 types of angle: a right angle, anything smaller than a right angle, which will be our acute angle, and then anything bigger than a right angle, which would be our obtuse angle.
Excuse me.
Yes, of course.
What class is this?
This is BA3.
So what kind of math are we learning over here?
So we're doing geometry right now. We're doing shapes and angles.
Geometry for which grade?
3rd grade.
Oh.
What grade are you in?
I'm going to 9th grade.
Okay, so this might not be the right class for you then. Yeah, there might be a more advanced class at like a different time or day. So you might have to contact the administrator to see which class would be a better fit for you. Because if you're in 9th grade, this will probably be too easy for you.
Okay, yeah, thank you.
Yeah, no worries. See ya.
See ya.
Okay, so let's see if we can do question 8. We'll just work on it together so we can get a little bit more of practice with our acute and obtuse angles. Okay, so if we go in a straight line here, do you think we can go up, or do we just have to keep going forward? Right? Alan, what do you think?
Go straight forward.
Yeah, right? We can't go up because this is an obtuse angle, right? It's greater than 90 degrees. So we keep going forward. And now we can go down, right? If we go down and left, right? This angle right here is an acute angle. We go down. And then we can also...
Sure. I think we go down again.
Yeah,
the
right?
left.
We go
To
down
the
and
left. To the
again.
left.
Yeah, right? The same thing we just did earlier, right? And then let's go all the way across here. And we go up. And let's see, should we go Should we go left, up, or right?
I think we should go right.
Yeah, right?
Right.
Because if we go up, this would be an obtuse angle. And so we're going to keep following this path, and then we get to the finish.
Yay. This looks like 2 staircases.
Oh, it does, right? If we went step down and then stepped back up. Okay, so does everyone understand what an acute and an obtuse angle is now?
Oh, now I do.
Yeah, now you do? Okay, great. If anyone else has any more questions, I can always explain it again, okay? Everyone's good? And keep going on? Okay, so let's see. Does anyone want to try doing 9? Lydia? Okay, yeah, let me turn on annotations, and then can you draw on the screen with your mouse?
Like right now?
Yeah, I don't know.
Oh, I know the answer
No.
since I now know what these mean.
Uh-huh. See, can you draw on the screen? Otherwise, you can just tell me what to do, and then I'll do it for you.
I can't draw on the screen.
Okay, I'll just do it for you then. Okay, so
I know.
okay, so let's let Lydia go right now.
Okay.
Okay, so let's see. I'll go straight here. Should I go up or to the right?
To the right.
Nice. Yeah, so we'll go to the right. And then now where should I go? Should I go left? Should I go left, up, or down? Let's see. Let's look at our options, right? If I go straight up here, that looks like it's going to be bigger than a right angle, right?
Yeah.
You guys can see my
So-
mouse, right?
What?
You guys see my mouse?
Yeah.
If I wave it in a circle like this? Okay, cool. So then we should go up this direction, right?
Yeah.
Okay, and if we follow it, we go this way, and then, oh wait, sorry, yeah. But then if we go this way, we can't go down or right. So let's see if we can try a different path. What if we go up this way? This is an acute
Yeah.
angle. And then we can go down, right? Okay, so what do you think I should do next? Should I
You
go
could.
up or should I go right?
You could. You could go up.
Yeah, I could go up. Great job. Right? If I go right, that's going to be a right angle. Right? So if I go up here and then we can go down again, right? If we go to the right, this is going to be definitely an obtuse angle, right? So we can go here. And we can either go straight down or we can go up. So let's see, if we go straight down here, right? This is a right angle.
So we go up.
Yeah, great job. And then if we go, this is an obtuse, if we go right, it's an obtuse angle, but if we go down, that's an acute angle still, right? And if we go up, and then we can go to the finish. So now we just have this really big ziggy-zag line. But all the angles are acute. Right? Do all the angles look acute to you guys?
Certainly it does.
Yes, great job. Okay, so now let's try 11. We can do one, but instead of acute angles, we're going to be doing obtuse angles. So if we go straight here, oh, wait, sorry, for 12, we're going to be doing obtuse. So let's do 12 since we've already done a bunch that have acute. Alan, you want to help me with this one?
Excuse me.
Yes.
I think there are 2 Allens in the class.
Oh, sorry, you're right. There's an Alan Lee and an Alan L, right?
Lee. Same last name, I believe. So
Oh, okay. Okay, we'll call Alan, one of the Allens, Alan, Foxhead Alan, since he has his fox head. And then we'll call the other one just normal Alan then. How about that?
Yeah, maybe I'll change his name to Qi Qi. So
Okay,
that will be
yeah.
easier for you.
Okay, yeah, that works.
I'm already drawing.
Okay, yeah, that looks great so far. So Alan, right, if we go this way, we're going to be using, that's an acute angle, right? This angle right here is acute. So let's see if we can find an obtuse angle. Right, this angle is acute, so it's hard because we're switching from acute to obtuse now. Do you want to try again? Yeah, right, that's an obtuse angle, so we can go there. Yeah, that looks great. And let's see. Yeah, you want to keep going? Yeah, right, these two, right here, and right here. These are all obtuse angles because they're greater than a right angle. Amy, Scarlett, do you guys have any questions, or do you just want to help me with the next couple of problems?
I just wanted to help you. For me, I just want to.
Okay, great. I'll let you help for the next problem then, okay? You too, Scarlett?
Yeah.
Okay, cool. You guys can do the next two problems then. So yeah, Alan's finished this one. Great job, right? We can see all of these turns that we made are obtuse angles because they're all greater than a right angle. So let's see. Okay, we'll clear this now. And so triangles have 3 sides and 3 angles. So a triangle can be named by letters at the 3 corners. So right, this triangle would be called ABC because those are the points at the edges of all the triangles. So a triangle with 3 acute angles is called an acute triangle. So we can see all 3 of these angles are smaller than a right angle. And a triangle with 1 right angle is called a right triangle, right? This angle right here is a right triangle. It's perfect. One edge is perfectly up and one edge is perfectly horizontal. So this triangle DEF is a right triangle.
So you mean every triangle with at least one right angle and or like one corner, then it's that named corner.
Yeah, so that's only for a right triangle, right? Because this right triangle also has 2 acute angles. So an acute triangle has to have 3 acute angles. A right triangle just needs to have 1 right angle. And an obtuse triangle just needs to have 1 obtuse angle. 1 obtuse angle. Right, because this obtuse triangle still has 2 acute angles. If it had more obtuse angles, right? Imagine if this was obtuse, then it wouldn't have 3 sides, right? It wouldn't be a triangle anymore. So right triangles and obtuse triangles still have acute angles. And so whenever we name a triangle, the order is not important. So this triangle ABC can be ABC, CAB, BAC. It just has to have all 3 letters. Okay, let's see. So Amy, you can help me with this next problem. Every triangle can be named 6 ways. 2 ways to name the largest triangle in the diagram are WXZ and WZX. What's another way we could name this big triangle?
I don't get it.
Okay, so let's see. Let me explain it a little then. Yeah, it's a little weird. So we have this triangle, right? We're trying to name this big triangle, which has each of the corners named W, X, and Z. So if we want to call this triangle, if we want to tell someone we're referring to this triangle, we can call it WXZ, right?
We can call it XZW.
Yeah, we can call it XZW too. As long as we use all three letters, we can put the letters in whatever order we want.
We
Right, so
could
yeah,
also call
WZ.
it
XWZ, right.
we
have
can
two-
also call it ZWX.
Yeah, right. One more way.
XWZ.
So we already have XWZ, but there's
Oh.
another one that we can start with a Z, right? We can do Z, and then what?
ZXW.
Yeah, great job, guys. So those are the 6 ways that we can name this triangle, the big triangle. And so in this big triangle, we have 2 smaller triangles, right? So how would we name the 2 smaller triangles inside the big triangle? Does anyone have an idea? Scarlett, you want to help with this one?
I don't get it.
Okay, so let's see. So we have this big triangle, right? And inside we can see, look, there's this triangle here. Wait, let me use my highlighter so we can see it better. We can see how, oh, never mind. I'll just use the pen then. We can see how there's this triangle, right? There's a smaller triangle and the big triangle. How would we name this triangle, right? So to name a triangle, we have to use the letters at the corners of the triangle. So how could we call this triangle I've just drawn in blue?
ZYW.
Yeah, great job, right? And then let's see, there's another triangle up here, right? Here's another triangle inside. Let's see. Fox Allen, you want to try, do you know what we could call this triangle?
See, what's the
No.
name?
XWY.
Yeah, right, we're going to use the 3 corners, X, W, and Y. So we want to name all these different triangles, right? Because if we had this triangle and someone just said, oh, find the angle of the triangle, we wouldn't know which triangle to use. So this way we know which triangle someone's talking about, right? If someone says triangle ZYW, we know they're talking about this triangle, ZYW. Or if they say XWY, then we know they're talking about this triangle. Okay? Does that make sense, or should I explain it again? Oh, good job, Lydia. Okay, so if no one has any questions, we're gonna keep going on, okay?
Makes sense to me.
Okay, great job. Yeah, so if you have any questions or if you don't understand anything I just said, please raise your hand so I can explain it to you so no one gets left behind, okay? So which of the 3 triangles in the diagram above is a right triangle? So remember, whenever we look for a right triangle, we only need 1 right angle. So let's see, can we find a right angle? It looks like this is a right angle, right? This corner looks like it could be the corner of a rectangle or a square. So that means our big triangle is the one that's a right angle. Yeah, Amy, that one, nice. So that we could call that one just XWZ. Of course, like we said in 13, there's a bunch of different ways we could name it. But as long as we use all 3 letters at the corners, yeah, nice, Alan, then it doesn't matter. So let's see. Which of the 3 triangles in the triangle above is an acute triangle? So remember, whenever we have an acute triangle, it needs to have all 3 acute angles. So does anyone think they could find the acute triangle for us? Amy, you want to give it a try? Yeah, great, right? Our smaller triangle. Oh, good job, Scarlett, you too, right? Because all of these three are acute angles, right? They're all smaller than 90 degrees. So XWY. And then which of the three triangles in the diagram above is an obtuse triangle? Remember?
Now I'm just messing around.
Yeah, let's try not to draw on the board unless we're talking about the answers, okay? So it's not too confusing for everyone else. Let's see, remember an obtuse triangle, we only need one obtuse angle. Let's see, does anyone have the answer? Let's see if anyone who hasn't answered yet wants to give us an answer. Okay, yeah, I guess Amy and Scarlett have already drawn on the board. But let's see, so let's pause drawing on the board for a second. And so, right, it's this bottom triangle. This corner right here is bigger than a right triangle, right? It's much wider. So that means, so we know that this triangle at the bottom is going to be our obtuse triangle. Got it? Okay, so let's go back to the guide real quick. So this is what we just covered, right? That's me, hearties. Behold the triangle. Every triangle has three sides and three angles. So that's what makes a triangle so strong. A triangle will not collapse without bending one of its sides. Allow me to demonstrate. If I assemble 4 planks to make a square, it's flimsy and frail. It'll just tilt and bend over. But assembling 3 planks to make a triangle, and it'll stand up. It's sturdy and robust. So he asked, what can make a square stronger? Lifting weights. But we could add a bar to make 2 triangles instead of just one big square. So that's why a lot of houses and bridges and bicycles all have triangles, because they're really strong shapes. So in a right triangle, if we split up a square, we get 2 right triangles. A right triangle, one of the angles has to be a right angle. And so it says, what do we call a triangle with 2 right angles? It says, I don't think we can have a triangle with 2 right angles, right? If we had 3 sides and 2 right angles, excuse me, we would just have this U shape, right? It wouldn't be a triangle. It's not a closed shape. So no triangle can have more than 1 right angle, but a triangle can have 3 acute angles, right? And which is called an acute triangle. So acute triangle, all 3 have to be acute, just like what we saw. If all 3 angles are obtuse, isn't it an obtuse triangle? No, right? Just like we saw with the right angles, if we have too many angles that are really big, then our sides don't connect. So this is an acute triangle, right? All of the angles are acute. This is a right triangle. We have 1 right angle right here. Oops, that's yellow. We have 1 right angle right here. And we have obtuse, right? We have 1 obtuse angle on our obtuse triangle. And so there's also other ways we can use to describe the triangles. So right, when we describe the triangles here, we were using the angles to describe them. And so we can also use the sides to describe them. So if all 3 sides are the same size, right, the same length, it's an equilateral triangle because all the sides are equal. Equilateral means equal-sided. So any shape in which all sides are equal are called equilateral. Every equilateral triangle is also an acute triangle because look, if the sides are the same length, the angles will be acute, right? We can see here all our sides are the same length and all our angles are acute. If only 2 sides are the same length, then it's called an isosceles triangle. Isosceles. This isosceles triangle is acute, but isosceles triangles can also be obtuse or right angles, right? So this one in particular just happens to have 3 acute angles, but these 2 long sides are the same length with 1 shorter edge. And when no sides are the same length, all of them are different sizes, it's called a scalene. So this is a scalene right triangle. So here's a diagram of all the shapes we can have. So an equilateral right triangle or equilateral obtuse triangle isn't possible, but we can have isosceles acute, isosceles right, isosceles obtuse, and the scalene. And so it says, why do we need to learn all these different words for different kinds of triangles? Let's see, does anyone want to try helping us read the pages here? Otherwise, I can keep reading.
Can I?
Yeah, Amy, why don't you read the orange speech bubbles? And then, Alan, did you want to read too?
Sure.
You can read the pink speech bubbles. Okay, so Amy, you first. You can read these orange speech
Let's
bubbles.
play a game, Winnie. Come up to the front. I'll give you a card with a drawing at the top. You try describing it to the class so they can draw it. But there be a catch. You can't use any of the words on the card to describe it.
Sounds fun. I'll try. Let's see. It has one short line, one medium line, and one long line. The part where the short and medium lines come together at the corner. It's like, it's really big.
And so it's the letter K.
No.
He says, is it a cost volume profit analysis?
What on earth is that?
No, it's not one of those.
It's a Tyrannosuchus. And these,
No. It's a scale abuse triangle.
yeah, obtuse triangle, right? He said, oh, that's easy. Why did you just say so?
Those were the words I couldn't use.
Words can be coming in handy when describing a thing. 'Tis much easier to say scalene obtuse triangle than to say a closed shape with three sides that are all different lengths and with one angle that is open wider than a perfect L.
Yeah.
Anyone else want to try a card?
It says, I'll try. Okay. This is a flexible pulmonary suction powered pressure differential liquid transport cylinder. He says, I know, it's a bendy straw. Okay, so now we're going to do a couple more practice questions. Right, so we just learned about this, right? So when we're talking about angles, we can have an obtuse triangle, acute triangle, and a right triangle. And when we're talking about the sides, we can have an equilateral triangle, right? These sides, right? This side, and this side are all the same length. So it's an equilateral triangle because they're all equal. An isosceles triangle is when two of the sides have the same length. So that's called an isosceles triangle. And a scalene triangle is when none of the sides are the same. So right, these are all different lengths. So let's see, let's use the diagram below to answer the following questions. So let's see, so first all we have to do is name all the triangles. So let's see, can anyone give me the name of one of the triangles? Right, remember when we name a triangle, we use the letters that are at the corners. Let's see, Alan, did you want to try naming one of the triangles?
Yeah.
Okay, let's see.
JMK.
Yeah, JMK, right? JMK, that would be this triangle on the left.
I know one.
Okay, what's one, Amy?
JML.
Right, that's another one. Right, that's going to be our triangle at the bottom.
I already saw all of them.
Oh, you saw all of them? Okay, let's just go through them quickly then, right? We have this one on the left, so we also have one on the right, right? K.
And we have KJL too.
Yeah, right, we have this big one on the very outside.
Hey, did you know all of these lines make a 3D triangle?
Yeah, it does look like a 3D triangle, right? It almost looks like M is either coming out or like pushing back. But okay, let's see if we can name an equilateral triangle now. So an equilateral triangle, remember, is when all three sides are the same. So let's see which one of these triangles that we just listed looks like an equilateral triangle.
Ooh.
let's see if we can let anyone else who hasn't answered answer. Let's see. Jaden, did you want to try giving this one a problem a go?
Get what?
So we're doing question 19 right now. Can you name an equilateral triangle? Remember, an equilateral triangle has 3 sides that are the same length.
KJL.
Yeah, KJL, right? These sides look like, this triangle looks like the triangle we just looked at for an acute triangle, right? All of the angles are acute and all the sides are the same length.
Look, KJ look,
Yeah, so great job. Let's see. Now let's see if we can name 2 scaling triangles. Gia, did you want to go?
It's KJM and KML.
Yeah, right. So KJM and KML. Right, none of these side lengths are the same. And so there's 2 isosceles triangles in the diagram above. Let's see if we can name both of them. Remember, a triangle with at least 2 equal sides is an isosceles. So does anyone want to try to name some isosceles triangles? Let's see if anyone who hasn't, let's see if anyone who hasn't answered one wants to answer. Luca, would you want to try answering this one? You can just name one isosceles triangle if you can.
So an isosceles triangle.
Yeah, so that's just a triangle with at least 2 equal side lengths.
It is M to L to J.
Yeah, great job. MLJ, right? These 2 sides are the same length. And then this last one is really tricky, but KJL is also an isosceles triangle, even though it's an equilateral triangle, right? So a triangle that's isosceles has to have at least 2 equal side lengths, but it can have more than 2 equal side lengths. So that means all equilateral triangles are also isosceles triangles. So now we just did the angles and we did the angles and the sides separately, but every triangle can be described by both its angles and its sides. So this is an isosceles acute triangle, right? Because we have 2 sides that are the same length, and we also have all acute angles. So now we have some shapes that we can match together. So let's see if we can find an isosceles right triangle. Which one?
Fun fact. You can fold a circle to make a triangle.
Oh yeah, you can.
Yeah, I guess that's
type
true.
in. But this is not, I guess it's not really a circle. It's just a shape that says impossible. So if any of these are not possible, then we can draw it to the impossible circle. Okay, so does anyone think they know which one of these is an isosceles right triangle? Alan, you want to try going?
Yeah. So
Why is the circle marked impossible?
Well, so some of these, or at least one of these scenarios is not possible. But an isosceles right triangle is possible, right? So which one of these shapes is an isosceles right triangle?
okay. It's hard to, but it's the bottom one.
The bottom one? So yeah, this bottom one does almost look like it would be an isosceles right triangle, right? It has this right corner, but all of the sides are actually different lengths. So it would be a scaling right triangle, right? This edge is our shortest edge, and it's longer than this edge, and then our diagonal edge is the longest. So they're actually all different. But this one triangle, the second one, this one has a right angle, right? The right angle is not always on the bottom left or the bottom right. And then these two sides are equal. And then we have one longer side. So this is our isosceles right triangle. And this one that you named earlier is going to be our scaling right triangle. So let's see, let's see if we can find a scaling obtuse triangle. Remember, so a scaling means that all of the sides are different lengths, and obtuse means that we have one obtuse.
I know.
You want, let's see if we can, if anyone else wants to try. Lydia, would you want to try answering this question?
It would be.
All right, so here, I'll number them so it's a little easier. 1, 2, 3, 4, 5, 6. So remember, scaling is where all of the sides are different lengths, and obtuse means we have one obtuse angle.
I think it's 3.
Yeah, so 3 is a really good guess. But yeah, 3 is a really good guess, but if we look carefully, it's kind of hard to tell, but this side and this side are actually the same length. It's really hard to tell though. So
Is it 5?
yeah, it's 5, right? Because we have one obtuse angle here, and then all of these sides are different, right? Here we have a shorter side. This side is longer.
Medium side.
Yeah, it's our medium one, and then we have our longest side. So this would be our scaling obtuse. Yeah, so sometimes it's really hard to tell which sides are longer than other sides, so we just have to compare them. But yeah, but then you helped us find 3, right? 3 is going to be our isosceles obtuse triangle. So what about an equilateral right triangle? So remember earlier, we were saying that all equilateral triangles are going to be acute, right? Because if we have an equilateral right triangle, all the sides have to be the same length, and then one of our corners wouldn't touch. So we can only have acute equilateral triangles. So this one is impossible, which means our scaling acute triangle is going to be this one. Right? Does that look good to everyone?
Yeah.
Understand? Okay, nice.
Yeah. Oh, I know why one of them is marked impossible.
Yeah, right, because
The first time I even saw the circle with impossible on it, it actually creeped me out.
oh yeah, it's kind of weird because all the other ones are triangles. But right when we were looking at this guide, we can see that we can only have acute equilateral triangles. So right equilateral or obtuse equilateral triangles are impossible. Okay, so let's keep going on then. So in the diagram below, RTUV is a square, right? Just like we name triangles, we'll name squares the same way. As we just have to hit all of the letters on the edges. So right, RTUV is our square. So that means we know that all of the corners of the square are going to be right angles. So now let's see if we can answer the questions. How many right triangles are in the diagram above?
Fun fact, in one of the games, I already deleted it a long time ago, but in one of the games, like a brain game, the brain game, it has a lot of impossible for you questions, but one of them was very similar to how many triangles is in it. But sometimes we can miscount some triangles.
Yeah,
so it's very tricky, but I got used to that. So now I know the answer.
Okay, so let's see if you already know the answer. Let's see if we can let other students give a chance to get the answer. But that's great that you use other games to help you figure out these problems. So let's see. So we know that the corners of the square are right angles. So let's see if we can find some right triangles. Let's see, someone who hasn't gone. Hannah, would you want to see if you can try to name one right triangle? Hannah, you want to help us? Okay, otherwise, let's see. Amber, you want to see if you can answer? Yeah, Amber, do you want to see if you can name a right triangle for us?
TUV.
TUV. Yeah, that's a great one, right? This is going to be our right angle. So we know it's a right triangle. So we have one, we have TUV. Let's see, Gia, you want to see if you can name another right triangle here?
It's CRT.
Yeah, that's great. That's another one, right? Our right angle would be here. TVR. And so let's see, we have one more, right? We can see that this right angle also can be used for this right triangle. BRW. So that means we have 3 right triangles here. So now let's see, now it's going to give us a triangle and let's see if we can describe it. So let's see if we can describe triangle TUV by its sides. So triangle TUV, right? That's the one we just named earlier. So since we listed that one earlier, we know it's going to be a right triangle. A right triangle. And now let's see what we can say about the sides, right? If this is a square, we know this side and this side are the same. And this diagonal line is going to be a little longer because it has to reach from these two. So it's going to be, if it has a right angle and 2 sides that are equal, what are we going to call it then? Someone want to answer?
Right.
Yeah, so it's a right triangle, but how do we describe the sides? Equilateral, isosceles, or scalene?
Equilateral.
Well, no, remember we said this diagonal line is going to be a
Oh
little.
yeah.
Mhm.
I accidentally saw the wrong thing.
Oh yeah, no worries. But right, if we have 2 sides that are the same length, it's going to be isosceles, right?
Yeah.
Isosceles. Right triangle. So now let's see if we can describe triangle RST by its sides. RST. Right, so let's look at our angles first. So all of these angles look like they're smaller than 90 degrees. So it's going to be, what triangle, what kind of angle would we use? Acute, right, or obtuse?
Acute.
Yeah, great job, acute. And then what about its sides? The sides all look the same length, right? And we know acute equilateral triangles are possible. So then we can say that this is going to be an equilateral acute triangle. Okay, so that's all of the questions we're going to be doing for today. I'm going to give you guys a little bit of homework for class next week, okay? So from page 13, I want you guys to do questions 31, 32, 33, and 34, okay? Basically, we're just gonna do-
But I don't have the Beast Academy thingy.
Oh, you don't? Okay. Do you have the guidebook?
I don't have anything about Beast Academy thingies.
Okay, let me see. I'll talk to the person and I'll try to get them to send it to you, okay?
Thingies.
I also don't
What?
have. I also
Okay.
don't have.
Okay, well, let me-
got them. I've got
okay, so if you guys don't have the problems, then I guess we won't have any homework tomorrow for next class. But I'll talk to the administrator and I'll see if I can get you guys these materials, okay?
Okay.
So I guess for next class, we won't have any homework then. So we'll just finish up a little early, okay? Does anyone have any last minute questions?
No.
Hey, what happens when I was trying to help my sisters? What?
Your sisters? Oh, are your sisters in the call?
No, Jaden Wu wrote that in the chat.
Oh,
You know how to mute.
yeah. Do you want me to mute you or what? It's okay.
It's
Oh, maybe it's just something happened to him. That's okay. So if anyone has any questions, you can stay after a little bit and ask me for help. But otherwise, you guys are free to go. I'll see you next week, okay?
Bye.
Bye.
Guys,
Thanks. Bye-bye.
Bye.
thanks for coming, guys.
Bye. I'm leaving.
Okay, see ya.